chapter that we're going to be learning. This is probability. Now, don't worry that, the chapter starts at 8G. That's because statistics, which is what we learned earlier in the year, is a part of this chapter as well. And we've already just covered that section already. We're just focusing on the probability part of it. Okay. So let's just go through it. So hopefully by the end of this video, these are these are the three things that we will achieve. So we're going to understand that probability is just a number, and it's just basically a number that's between 0 and 1. Now we need to know the meaning of key terms, and then finally we're going to calculate the probability of such events. Okay, so let's just get through it. Now, this seems like a long drag, but like we just have to make sure that we know our definitions and know which one's which. Um, I'll create like a sheet having all the definitions, and that way you could just like have it in your book somewhere. Okay, so don't worry too much. Um, First one is experiment. So it's a situation or action that can produce different results. So just think of like, a science experiment, like when you're doing your science practicals, you are doing an experiment pretty much most of the time. So basically, you go through the whole process and then you're just waiting for the outcome. That's it. But in math and probability, it's mainly like something like you flipping a coin like 50 times or something, stuff like that. A trial is just something where you can repeat the same thing and then you're just going to like record your results. So, for example, flipping a coin, rolling a die, or spinning a spinner. An outcome is just any possible result, okay? Any possible like basically, so if you think about it, flipping a coin, there are two outcomes there. You got heads, you got tails. That's about it. Single outcome is just basically you just stating what it is that that's going to happen or what you want to happen. My example here is rolling a three, or you can, it doesn't even have to be one thing, you could do like a collection of things as well. So in this case I have rolling a 3, a 4, or a 5. Let's see here. The word at least just means the like think of it like the minimum. Okay, like you can think of it like the minimum number or the minimum value. So, and it's just like whatever it is that's above it. So in my example here I have at least 2. So that means 2 is my minimum right here. And basically just any higher number. So, for example, if I roll a die and the question asks, what's the probability of rolling at least a 2? Then, you'd count 2, 3, 4, 5, and 6. And that's just how it goes. Next thing is at most. It just means the maximum, okay? That pretty much just means the maximum number, the maximum value. So my example here is at most 3. That means 3 is the highest number that I count towards, and I'm just going to include every other number that's below it. Okay, so in this case, I have 0, 1, 2, and 3. Now, the word or, it's a bit weird. Okay, so it's like I can have, we're just going to call one event A, and we're going to have a second one B. So it could be A or B. It doesn't really matter. That's just what we want. But the true definition or the simple definition of it is this: it could be one event, it could be the other one, or it could be both events happening at the same time. You don't know. So basically, if A in this case is getting an even number, if I roll a die, it's like, all right, sweet, I have 2, 4, and 6. And then B is saying, hey, I want any number that's greater than 4. So that's 5 and 6. So whenever you say A or B, you pretty much combine all the outcomes together. So whichever one satisfies the conditions of both events here. So I have an even number, so 2, 4, and 6. And then I also have getting a number greater than 4. And my options were 5 and 6. So I'm going to include this 5. This 5 gets chucked in here as well. So think about it like this. If I roll a die, I'm gonna be like, hey, I want an even number, but also like I wouldn't mind a number greater than 4 as well. So my chances of rolling this kind of condition here is actually 4 out of 6. The next one is and. So basically two, possibly more events happening at the same time. So if you have a look at my example here, event A getting an even number, event B getting a number greater than 3. And if it's the word and, I have to look at each number in each event and just find the ones that they have in common. So in this case, I have 4 sharing in both, and then I have 6 as well. So that's why the final answer is just 4 and 6. So that's just how it is. Those are just definitions right there. Now, this formula here, this is your bread and butter. Okay, to finding probability. So how it typically works is the question will say, hey, find the probability of whatever. You are going to first find the number of favorable outcomes. The number of favorable outcomes is just basically um, the result that we want. So how many options are there available? So if you think about it, it's like, hey, what's the probability of me rolling a 3 on a die? On a six-sided die, there's only one 3 on the die, yeah? So obviously that means you're gonna put your favorable outcomes as 1. Now, the denominator, the total number of outcomes, just means, okay, on the die, like, how many faces are there, or like how many possible total outcomes are there? Obviously, it's 6 sided die, so you would just say 6. That's just all it means, okay? So make sure you have this. This is very important right here. And you don't need to write this, but remembering back to our learning aim of probability is a number between 0 and 1. So if you have a look, probability is typically written as fractions, okay? And they'll always be written like that, or they could be written as a decimal. But the one thing you must notice is that the numerator always smaller than denominator. Okay, that's all it is. And that satisfies the condition of probability is number between 0 and 1. Okay, it satisfies that condition right there. Now, these are just some examples here. If a six-sided die is rolled, what's the probability of rolling? Now, you must make sure that you do this. You must write. This is must. Okay. I am going to force you to get into the habit of writing this kind of stuff. PR just means probability. Bracket stuff is just like this stuff. It just describes what you're finding, what you are finding. Okay. So in this case, I have what's the probability of me rolling a 4? As you can see, I wrote PR brackets. And then what's my description that I'm trying to find? I'm trying to find if a 4 is being rolled. And then obviously you just do your number of favorable outcomes over the total number of outcomes there are, and you just put it in. Do not write your final answer just as a fraction. Please make sure that you write PR, the description of it, and then you write your fraction, okay? Now, you must always simplify your fractions, okay? There are no excuses. I'm letting you know now, okay? Sample space. Sample space is the set of all possible outcomes. So you're going to list them, okay? You're going to list them. So make sure you write them out. So, um, what you always do is you write this fraction, okay? Uh, put sample space inside this bracket. Now, how you would start off is you'd say, okay, I start from the top, I meet in the middle, this is where I end. Same thing. One, two, three. That's the order you draw, okay? Order you draw. Or that's how I typically do it. If you do it the reverse way, then obviously you do that way instead. As long as the bracket looks clear and it's one of these weird looking squiggly brackets instead, okay? So just going through some examples. The sample space of a coin is heads and then tails. Make sure you list them out and you put a comma in between every single one of them. And then you have the sample space of rolling a six-sided die is 1, 2, 3, 4, 5, 6. Make sure you list them out properly. Okay. Now, the next thing is complementary. It just literally means not, or it could be opposite. You can think of it like opposite as well. Like that's another way of phrasing complementary. Now, it's always written with an apostrophe. So make sure your apostrophes are really clear as well. Don't make it look like a comma. Actually, make it look like a nice, clean apostrophe. Now, how you would typically write things, let's just say event A is, they've labeled event A as this. How you typically write it is a dash, like pronounced as, how would I'll just say pronounce as a dash. Okay. Now, an example that I have is, okay, if my event A is rolling a three, then the complement of rolling a three just means rolling a number other than three. Okay, so what's my chances of me not rolling a three? And then that would be your A dash right here. Okay. Now, this is a formula that you need to have. Okay, make sure you have right here. This is something you need. So basically, if you think about it like this, let's just say A equals rolling a 2. That means A dash means not rolling a 2. So think about it like that. So we know PR of rolling a 2 is 1 over 6. And that means the probability of not rolling a 2 would be 5 out of 6. And if you put it together in the formula, it would just equal to 1 whole. So that's why this formula is really important. This formula is technically used to help you find the complementary, or but like if you need to find the other side of things, like let's just say you're given the complementary probability, you need to now find what's the probability of the main event. Okay. Now over here it's a bit weird, but I will go through the first one. Okay, I've already written it out, so I'll just explain it. So it says here, find PR of A dash, find the probability of A dash if the probability of A equals to 3/5. So what you're going to do is just going to use the formula, okay? Always use the formula. So what I do is I'd always write out the formula, and then at the following step here, I substitute. So look at what I'm given. I'm given PR of A equals to 3/5. I can just substitute wherever probability of A is and write it as the fraction 3 out of 5. And then the next step is to just solve for PR of A dash. And that's it. And if you remember the solving skills that I taught you from last term, that would be how you would process things. Okay. Now, When it comes to fractions, it's a bit shaky. Okay, like I'd prefer if we were comfortable with adding or subtracting fractions. So I would like it if people practice how to do that from now on and just keep doing it. Okay. What I do is I end up with this 1 minus 3/5. And how I got my final answer is take the denominator, um, take denominator, multiply by whole number. So when you multiply by the whole number, in this case, the whole number is 1. So I just go, all right, what's 5 times 1? Okay, that's 5. That means this becomes the numerator. Okay, see? It becomes a new numerator now. Now the denominator just stays the same. Don't worry about that. But just focus on the numerator. In fractions, how you're supposed to add and subtract fractions is to make sure the denominators are the same. And then once you have them being the same, you can just apply the operation on the numerator. So if you have a look at what I've written here 5 over 5 minus 3 over 5. Because my denominators are the same now, I can just go to the numerators and just go 5 minus 3, which just equals to 2. And that would be my final answer. It's 2/5 in this case. Okay. Now, if you're looking for further explanation, I can work with you in person and I can show you the shortcuts. But the whole point is you must show full understanding as to how these fractions work. Okay. You need the skills to back it up before you start applying shortcuts. Otherwise, the shortcuts will not make any sense. Now, let's move on to the second one. Find the probability of B if probability of B dash equals to 0.8. So just instead of writing the formula in context of A, you can just write it in context of B, of the letter B instead. So I'm going to write out the formula and then I'm going to substitute what I'm given and then I just solve it like normal. So in this case, what I did was I subtracted both sides by 0.8 and 1 minus 0.8 is 0.2. Now, the reason why this formula is so awesome is because you know that the probability of a regular event and the probability of the complementary will always just add up to one whole. So you don't need to be scared as much if it looks a bit confusing. Don't worry about it. As long as you just remember these simple rules, I'm pretty sure the answers that you will achieve, they will be correct. Okay? Now, if you just look at this activity here, I'll just go through it really quickly. So it's just B. I'll just write out my formula. Probability of A plus probability of A dash equals to 1. I am given PR of probability of A. So I know what that value is. I'm going to substitute it. It's 1. And now I just solve like normal. So I minus both sides by 5, 6. Now I get A dash equals to 1 minus 5 over 6. Okay, take this, multiply. So it now becomes 6 over 6 minus 5 over 6. And that just equals to 1/6. So the probability of A dash is 1/6. You're done. Okay, this is your final answer. See, that's it. Now, find the probability of E if probability of E dash is 3/10. So just write it out again. Equals to 1. So I'm just gonna make it look neater again. So I'll just go 3 over 10 equals 1 plus PR of E. And now you subtract both sides by 3/10. This will be PR of E equals to 10 over 10 minus 3 tenths. I have sort of skipped a step, but that's just what happens when you run out of space. So 7 tenths. Now, the shortcut, if you wanted to know, is if you look at that, if you look at the numerator and you compare it to the denominator, it's like, what's the difference between denominator and numerator? So in this case, it would be equal to 7, yeah? So this 7 is technically your new numerator, but your denominator stays the same, okay? That's pretty much the trick right there. Now, with that being said, you can now work on these 8G exercise questions. Please give it a go. If you need help, please let me know. That's what I'm here for. Um, if you don't want to like ask for help in class, come see me Wednesday after school, okay? All right, take care.